Okay, we're doing number 5 on the kinematics problems, and it reads, you're driving your car at 14 meters per second. You increase your speed with a constant acceleration of 12 meters per second squared. So I've got those labeled here. You're already driving your car at 14 meters per second, so that is an initial velocity. You're already moving with a certain speed. You're not starting from 0 in this case. And you accelerate at 12 meters per second squared. How much time must you accelerate to reach a speed of 20? So my final velocity is going to be 20. Now, if you understand what acceleration means, you know that this means that we gain 12 meters per second of speed for each 1 second of time. So just keep that in mind. For every 1 second that goes by, you're going to gain 12. So if I'm going from 14 to 20, what would you expect your time to be? So just think about that. And then the next thing you're going to want to do is take a look at your list of equations. So look here, I've got initial velocity, acceleration, final velocity, and time. Which one of my equations fits the bill? Take a look. And this is the one that I would use. Final velocity is equal to initial velocity plus acceleration times time. So I'm going to go ahead and write that down. V final is V initial plus acceleration times time. Now, I want to solve for time, so I'm going to do V final minus V initial. And then I have to divide by acceleration on both sides. And that gives me how I would find my time. So I'm going to go ahead and plug those in. 20 meters per second minus 14 meters per second divided by 12 meters per second. It's going to be equal to my time. So I'm going to go ahead and do that. I'm going to take 20 minus 14 divided by 12. And I get a time of 0.5. Now, does that make sense to what we just said a moment ago as to gaining 12 meters per second of speed for every 1 second of time? Well, how much speed did we gain? Didn't we only gain 6 meters per second? So we gained 6 meters per second of speed, didn't we? Went from 14 to 20. Well, if I gained 12 for every 1 second, how long did it take us to gain 6? It took us half a second. So that's how you can check and see if your answer is right. So that's number 5. Okay, this is number 7. And number 7 says a car has an initial velocity of 30 meters per second, and then you hit the brakes. You slow down for a total of 8 seconds, and in that 8 seconds, you travel 95 meters. So it would look something like this. You've got your fancy schmancy car, you're driving along, and you're going 30 meters per second, and then all of a sudden, boom, you start to slow down, you hit your brakes, and for a total of 95 meters, which takes a time of 8 seconds, your car slows down. And it wants to know, in this interval here, how much did you decelerate, or what we call a negative acceleration, because slowing down means a negative acceleration. So you've got your initial velocity of 30, a time of 8, a position of 95, and we're looking for A. So if you use your position formula, x is equal to VOT plus 1/2 AT squared. We have all of those components. We have x, we have initial velocity, we have time, and we have acceleration. So you can just go ahead and plug in your numbers and solve, or you could solve for acceleration first and then solve. So let's plug our numbers in first and solve. So I've got 95 meters, that's my x, equals 30 meters per second, that's my initial velocity, times my 8-second time, plus 1/2. A, we do not know. That's what we're trying to solve for. And 8 seconds squared. Okay, well that's kind of hairy, so we're gonna clean this up a little bit. So I've got 95 equals, and you're gonna do 8 times 30. $240, and this is meters, because meters per second times second, those cancel, so I get meters, plus 1/2 A and 8 squared, 64. So I'm going to subtract 95 minus 240 equals 1/2 A, 64. So we do 95 minus 240, negative 145 equals, and I'm going to go ahead and take that half of 64, divide by 32 on both sides. I'm going to take 145 divided by 32, and I get a negative 4.53 is my acceleration, and my unit is meters per second squared. This is meters, and on this side this was squared, so it's seconds squared. And the negative means that it is slowing down. Okay, this is number 12. And it's a free fall problem. It says an object is dropped from rest. It reaches a speed of 25. How far did it fall? So what we know is it's dropped from rest, so our initial velocity is 0. We know that it has a final velocity of 25. We know that acceleration due to gravity is minus 9.81 meters per second squared. And we also know that we're looking for y. So we want to know how far did it fall. And so there's a couple different ways you can go at this. You can use the first part of this, so you can use the initial and final velocity plus the acceleration to solve for time. And then once you have your time, solve for position. And that's probably the way that would make most sense for you to take a look at how to do this. The other way you could do it is you could use this other equation down here. This VF squared is VO squared plus 2A, and instead of delta y, you would plug in delta x. So it's velocity final squared plus initial velocity squared plus 2 times the acceleration change in y. So either way is fine. I'm going to do it the first way because those equations are going to feel more familiar to you. Those are the ones we're going to use most often. So I'm going to go ahead and solve for time first. So final velocity is initial velocity plus acceleration times time. Well, my final velocity is 25. My initial velocity is 0. I have negative 9.81 meters per second squared times time. I'm going to solve for time. Cancel, cancel. And I get 25 divided by 9.81, which is negative, by the way, 2.54 seconds. That's how much time it takes. And then I can use that in this equation, initial velocity times time plus 1/2 AT squared, except my initial velocity is 0. So I get y is 1/2 AT squared. So I get 1/2 of 9.81 meters per second squared negative times a time of 2.54 seconds squared. Oh, by the way, time is always an absolute value. There's no such thing as negative time, so we don't need to worry about negatives there. So let's go ahead and plug this in back down here. So 2.54 squared, this is how I would plug it in. I would do 0.5 times negative 9.81 times 2.54 squared, and I get negative 31.64 meters. And the reason it's negative is because it's falling down. And actually up here, your final velocity is technically negative too. Because if you're starting up at the top and that's your zero and you're falling down, we can call this velocity negative. So those negatives actually cancel out to get your time. But in general, if you end up with a negative time, you don't need to worry about that. It's absolute value. And we've got a negative 31.64 meters.